Hello viewers, welcome to Quick Coder. My name is Tulsi. Today's topic is partitioning an array. Okay, so this topic is very useful in the next topic that I want to explain, that is called quick sort. Okay, so this is also one important part of the quick sort. Okay, let's start. Let's get started. Start today's topic, partitioning an array. Now, so what is the main problem here is you will be given some pivot point. So this pivot point is 5. So what we should do is, so given an array, we have to arrange. So for suppose there is a 5. So the elements which are less than, okay, which are less than or equal to 5, they should be come in this part. Okay, the elements which are greater than 5 should be come here. Okay, I think you have understood. So the elements which are less than or equal to 5, they should come before 5. The elements which are greater than 5, they should come here. So like this, we have to arrange this array. So what is the main thing we are doing is, we have a very simple algorithm. What we usually do is, okay, now, first of all, we will check the present element. Is 7 is greater than 5 or less than or equal to 5? So 7 is greater than 5. Then what we simply doing, we are incrementing this I, means my I comes to here. My I is coming to here. See, internally something is happening. So first of all, trace that code. And now again we have to check. Again, is the array of I is greater than pivot? Then again we have to increment my I. Okay, now again I am incrementing my Now again I want to check, is my array of I is greater than pivot point? No, it is less than. So what I want to do is, I want to simply swap this array of j element and array of I element, because this array of j element will be exactly, it will be greater than this element. Okay, so we can say that. Now what we can do, we can swap this both I and j elements. Means here will be my 7 and here will be my 4. Here will be my 4 and here will be my 7. Now again what I will do, I should do I plus plus and j plus plus, means I will increment this both pointers. Here will be my j and here will be my I. Here will be my j. Now again I want to compare this array of I and pivot point. 8 is greater than 5. So simply I want to increment my I now. Now again compare. 3 is less than 5. So what we should do? We should swap this 9 and 3 and we should increment j and I. Means 3 will come here, 9 will come here, and my 2 pointers will increase. Okay, now again, is 6 is greater than 5? Okay, 6 is greater than 5. So I want to simply increment my I. 2 is less than 5. So what I want to do? I want to swap these two elements. Means 2 will come here, 7 will come here, and I want to increment my I and my j. Okay, now check. My 1 is less than 5. So again swapping occurs. Means 1 will come here, 8 will come here, and my 2 pointers, I will come here, j will come here. Is it true? No, j will come here. Okay. See, now my I pointers come to n. So this will be my array. See, up to 0 to j minus 1 will be elements less than or equal to 5. 0 to j minus 1 elements. See, 0 to j minus 1 elements will be less than or equal to my pivot point. And j to I minus 1 elements will be greater than 5. As no, j to I minus 1 element will be greater than 5, means nothing but here pivot points. Okay. So that's it. About this partition and array. Partition is nothing but we are partitioning according to the pivot point. So the elements less than or equal to pivot are coming before, at one half, and the remaining elements are coming at the other half. After the pivot. So we can simply insert this 5 into here, so that we will get all the elements less than or equal to 5 here and greater than 5 here. I think you have understood something now. So how to partition an array. So this not, we cannot use this partitioning an array problem separately, but this will be very useful in quicksort. Okay, this will be very useful in quicksort. So now let's start coding. So I think you may have understood, but the one thing that I want to say is, see, always we are we are always keeping j here only at the start, and whenever we occur the element which is less than 5, then we are swapping that, because we are always assuming that these elements will be greater than. Means again I will explain this point. I missed some small points, so I will explain that. 1 minute. The array we are taking, and we are always assuming the j pointer here and I pointer here. Now I'm checking this array of I is greater than pivot point. Now just I'm incrementing this I. But see here, the j pointer will always points to the element which is greater than 5. Okay, because if it is less than 5, so what we are doing, we are swapping, but it is not less than 5. So here the greater element is still having here. And this uh, again this element is checked with 5. Okay, it is greater than 5. Again we are having that element. Okay, so the j will be incremented now. Again the j can carry out this greater elements. Now whenever we encounter the element less than 5, so what we are doing, we are swapping that with greater element. So j always points to the greater element. Okay, we are swapping this 7 and 4. Okay, 4 here, 7 here, and we are incrementing my I and j also, because this is the greater element, and this is, see, this is greater element. We are storing again greater elements, means always j points to the greater elements. So that is the reason we are swapping that with array of I and array of j. Okay, so that's the small point that I want to say to you. So now let's start coding. Okay. Okay, they already given all the other snippets. So 1 minute is recording or not? Yes. Okay. So simply they already given swap function also. Okay, just few lines you can complete this. Okay, initially I am taking I as 0 and j as 0. Now up to where I'm running this loop, up to my I is less than array dot length. Okay. So if my I exceeds the array dot length, then I'm stopping there, because the array is already partitioned according to the given pivot point. Okay, now if my array of I is greater than pivot point, then what will happen now? I'm now incrementing my I press is equal to 1. So else what I'm doing, I'm just swapping this array. So already this function is there. No, in this function I want to pass array ij. So now I will pass array ij. Okay, now I will increment my I plus is equal to 1 and my j plus is equal to 1. So that's it. Let's run this code. Okay, it is accepted. So let's submit. I think my internet is slow. Okay, correct answer. Okay, so that's it about this partitioning array. But this part will be used in quicksort. Okay, so don't think that it is very easy, but the main part is there in quicksort. Okay, so to make easy, to make I mean to make quicksort is easy. So I'm separately explaining this partitioning array. Okay, so that's it about this video. Okay friends, thank you for watching this video. The coming up video is quicksort in Java, so let's wait for that. Okay, keep subscribe to my channel Quick Coder to get notified for the further videos. So thank you for watching.